Welcome back to Study Section 2 on SOS 201, Principles of Soil Science. In the previous study section, we discussed fundamental principles of soil science, but here we'll be talking about physical properties of soil. As we learned in the study section 1 of the course that soil physics is a branch of soil science that deals with the study of soil physical conditions. So it is necessary that persons dealing with soil in any moisture retention capacity, plasticity, ease of penetration by roots or compaction, the knowledge of physical concepts will enable the user of soil to know how to alter these properties to an advantages. At the end of this study section, you should be able to describe the concept of soil texture and its importance. Secondly, you should be able to identify the textural class of a sample of soil. Thirdly, you should be able to describe soil permeability and related properties. Fourthly, you should be able to describe structure and its formation and importance. Lastly, you should be able to explain other physical properties and discuss soil compaction and porosity. Let's talk about this linear outcome one after the other. Soil texture could be defined as the relative proportion of particle size groupings in the soil on a percentage basis. It describes the sand, slate, and clay composition of the soil. The smaller particle in a soil, the larger the internal surface area. Similarly, the smaller the particles in the soil, the more water and nutrients the soil can retain. So soil texture is studied because the rate at which water enters the soil, that is the infiltration, and drain through, which is being called percolation, depends on whether it's sandy, slate, or clay soil. Soil texture is also studied because of the rate of nutrients leaching. Also depends on the rate of water infiltration. For example, clay soils have the best holding ability for water and chemical nutrients. Also, soil texture influences the ease at which a soil can be worked. Clay soils are more difficult than sandy soils. So physical test for a soil reveals that sandy soil is generally coarse, gritty, non-sticky with low cohesion. So while slate is smooth like flour, and also clay is sticky and plastic when wet, but very hard when dry. A loamy soil texture usually exhibits a combination of all the three properties. So a soil sample usually contains a combination of at least two separate dust of the classes of soil texture. So the basic soil textural class names in use presently are defined in terms of particle size distribution as determined in the laboratory by a procedure termed particle size distribution analysis or mechanical analysis or gravimetric analysis. The 12 textural classes of soil are: we have sand, loamy sand, sandy loamy, loamy, slate loamy, slate, sandy clay loamy. We have clay loamy, slate clay loamy, sandy clay, slate clay, and clay. In this field, however, a method we known as field method is used in assessing soil texture. So in this method, a sample of soil usually is being wet, which is rubbed between the fingers, and the texture assessed by the behavior of soil particles using a knowledge of the behavior of the various quantities of the separate present in the soil sample. Soil structure may be defined as the organization of sand, slate, clay, and humus particles into somewhat stable groupings, that is the beds. It can also be defined as the aggregation of primary soil particles, the sand, slate, and clay, into compound particles termed aggregates or beds, which are separated by adjoining the beds by lining of weaknesses. So we have the three groups of characterize different kinds of structure, which are type, which revert to the shape of soil aggregates, that is granular and crumb. Also in terms of class, which is revert to the size of the pegs, e.g. fine, medium and coarse. Thirdly, in terms of grade, which describe how distinct and strong the pegs are. It expresses the differential between cohesion within aggregates and adhesion between aggregates. For example, we have the weak, moderate, strong or structureless terms being used for grade. Soil structure is important in agriculture from the point of view that a well-aggregated soil is often well drained and has good permeability of water, air and roots. So common agents of aggregation are responsible for binding primary soil particles into pegs, which includes 1. Colloidal clay minerals, which consist of the fine, more reactive part of clay in the soils. Colloidal oxides of iron, aluminium and manganese, which are collectively termed sequoids. These are especially typical of tropical soils. We have the microbe gums. They are gums which is being secreted by microorganisms in the soil. Organic compound, especially humus, which are also colloidal in nature. Soil consistency refers to the behavior of soil when pressure is applied, especially at various moisture contents, usually when the soil is wet, moist or dry. So the terms used to describe consistency includes soil wet soil. This is often described in terms of stickiness, non-sticky, slightly sticky, sticky, very sticky, and in terms of as non-plastic, slightly plastic, plastic and very plastic. The second one is moist soil. This is very important because it best describes the condition of soil when they are tilled in the field. Consistency of moist soil is described in the following terms, going from material with least coherence to that which adheres so strongly to resist crushing between the thumb and forefingers, and it can be determined as loose, very friable, firm, very firm and extremely firm. Dry soil. This term is used to describe the degree of rigidity or brittleness to crushing or manipulation into the following: loose, soft, slightly hard, hard, very hard and extremely hard. Cementation is also the type of consistency, and it is being caused by cementing agents such as calcium carbonate, silica or oxides of iron and aluminium. Cementation is little affected by moisture content. Soil compaction. Soil compaction is the natural packing of soil particles by natural force into a more dense or closer pack. These forces acting to compact soil are overburden weight of mineral above the soil, implement traffic from mechanized agriculture, foot traffic, tillage prior due to implements moved through the soil, microorganisms as in the ant hills. So soil compaction is measured by the bulk density and the use of cone penetrometer. Pores are space or voids between soil. Pores are space or voids between solid soil materials. The occurrence or abundance of pores in soil are of pedological significance because a soil with many coarse pores will be much more aerated and better drained than one with very few pores. So when describing pores in details, a definite sequence of terms should be consistently followed. The usual consequence in number: we have few, common, and many. For size, we have very fine, medium, coarse. Continuity, we have discontinuous, constricted, and continuous. Orientation, we have vertical orientation, horizontal orientation, random, etc. For shape, we have vascular, irregular, and tabular shape. And for location, we have impede and expede. So, pore space can also be defined as a portion of given volume of soil which is not filled with solid matter. Porosity or pore space refers to total pore space per volume of soil. So, an ideal soil for agricultural purposes has fairly equal proportion of micropores, macropores, and micropores. So porosity also depends on both the texture and structure of the soil or the shape of the particles. The density of a soil is its weight per natural volume or bulk volume, and it is related to the amount of empty space in the soil. So soil density is being expressed in two ways, which are bulky density and particle density. So particle density refers to the mass per unit volume of soil solids, while bulk density is the mass of soil per unit bulk volume of a dry soil. Soil theta. Soil state is the physical condition of a soil in relation to ease of tillage and permeability. So it is a function of textures and structure of the soil. Soil with good tilth makes room for rapid root growth and ease of seedling emergency. Soil teeth can be improved by improving soil structure and avoiding compaction by adopting the following particles. 1. Avoid working too wet or very dry soils. Reduce traffic or overburden weight of the soil. Number of tillage operation could be reduced as in a minimum tillage. Soil color. Soil color is an important indicator of soil conditions. It reveals considerable information about any given soil. Soil can take several shades of colors, such as brown-black, where dark soils result from the level of organic matter content, which is usually high in waterlogged soils. White, light gray. This indicates leaching of coloring materials, such as organic matter or due to accumulation of lime or salts. Yellow-red. These soils contain iron oxides. In well-drained soils, molten color. This develops when the soil is waterlogged for a part of the year. I hope you've learned one or two things from this video section. I enjoy you to kindly read over from your study materials to have deep understanding and knowledge of what we've been discussing since. Join me for the next study section. Thank you for listening.